You will also configure a guest wireless network. After the network is operational, you will configure email, transfer files, and investigate the email and domain name servers. Finally, you will explore how Packet Tracer simulates network communications. In Part 1, after investigating the networks in Greenville, you will connect home network components, including a cable modem and a home router. You will connect a wired printer and 2 PCs to the network. You will also configure wireless local area networks, or wireless LANs, for both family members and guests. Finally, you will verify all devices have connectivity. In Step 1, explore the 3 accessible networks in Greenville. In physical mode, click each location and explore each network. The data center is locked in this activity. Use the back level button to return to Greenville. ISP telco location. The cafe. And the home network. Switch to logical mode and click each cloud to view the logical topologies for the corresponding sites that you visited in physical mode. ISP telco. Home. And cafe. Switch back to physical mode. We will complete parts 1 and 2 in physical mode and part 3 in logical mode. Step 2 is identify the devices in the home network. Click Home and locate all the devices in the home network. There's a home wireless router, a home modem, a home webcam, a home office PC, a home printer, a home laptop, a family PC, a guest laptop, and a smartphone. Step 3 is connect the router to the modem. A technician from the Internet Service Provider, or ISP, has already connected the modem to the ISP telco network. We need to connect the modem to the home router. In the bottom toolbar, click Connections, and then Copper Straight Through. Click the home modem and choose port 1. Then click the home router and choose the Internet port. Step 4 is to connect the wired host to the switch ports on the router. In this topology, we have 3 wired devices: the printer, the home office PC, and the family PC. Step 5 is configure the home wireless router. Dynamic Host Configuration Protocol, or DHCP, automatically assigns IP addressing to devices connected to the network. Home routers typically ship with DHCP already configured, and quick start guides for owners to complete the network setup. Steps for the owner typically include connecting a wired PC to the new home router, opening a web browser, and then making configuration changes. Packet Tracer simulates this process. Click the Home Office PC, then the Desktop tab, and then IP configuration. Click DHCP to automatically receive IP addressing from the home wireless router, which will take a few seconds. Notice that the default gateway IP address is 192.168.0.1. Close the IP configuration dialog box and then click Web Browser. Enter the default gateway IP address 192.168.0.1 in the URL field and then click Go. Enter admin for both username and password and then click OK. The Home Wireless Router Graphical User Interface, or GUI, opens in the web browser window. Does this present a potential security vulnerability? Yes. The documentation for home wireless routers is easy to find on the internet. Anyone can attempt to connect to the router using the default login. If they are successful, they can make unauthorized changes to the network and possibly steal or damage computers. Let's take a look at how easy it is to find default router passwords. Simply type default router passwords as your search term, and you will see multiple websites. Let's click this one, routerpasswords.com. And it provides a drop-down list for selecting the router manufacturer. Let's choose Aries, which is a popular cable modem, and then find password. For this model, the username is admin and the password is password. Step 6 is modify the DHCP configuration on the home wireless router. In network setup, change router IP from 192.168.0.1 to 192.168.100.1. Leave the subnet mask as 255.255.255.0. In DHCP server settings, the DHCP server should be enabled. Change maximum number of users to 25. Enter 10.2.0.125 as the static DNS1 address. Scroll to the bottom of the page and click Save Settings. After a moment, we will lose our connection to the router. Why do you think that the home router dropped the connection to the PC? Well, the network address of the router has changed. It is no longer 192.168.0.1. We changed it to 192.168.100.1. First thing to do is to verify that the PC has received a new IP address from the DHCP server running on the home wireless router. Let's close the web browser and open up the IP configuration. And yes, you can see that it has received a new IP address in the 100 subnet. Notice that the new default gateway is 192.168.100.1. However, if you find issues with this, you can always open up a command prompt and type the command ipconfig/release. This will release the IP configuration currently held by the computer, and then enter ipconfig/renew to send out a new DHCP request. And we can see we have IP addressing that conforms to what we configured on the router. Now let's open a web browser again and type the new default gateway IP address and re-authenticate. I'm going to expand the width of this window a little bit. Step 7 is configure the family PC for DHCP addressing. In the bedroom, click Family PC, Desktop, IP Configuration, and then click DHCP to automatically receive IP addressing from the home wireless router. And we see that Family PC has now received a full IP addressing configuration. Step 8 is configure 2 wireless LANs for family members. In this step, you will configure the Service Set Identifiers, or SSIDs, for 2 wireless LANs. When you are in a public place and trying to find an available Wi-Fi network, the SSID is the name of the list of wireless networks available to your device. The SSID is not always broadcast to all users. It can be hidden as well. If it is hidden, then the user must already know the SSID and then manually enter it before the wireless client can connect to the wireless LAN. Return to the home office PC and reconnect to the home wireless router if necessary. Click the Wireless tab. In the basic wireless settings, notice that there are 3 wireless LANs you can configure. For all 3 wireless LANs, change the network mode from disabled to auto. For the 2.4 GHz and the first listed 5 GHz wireless LAN, configure the network name SSID to be HomeNet and select Enabled for SSID broadcast. Scroll to the bottom of the page and click Save Settings. Step 9 is Configure a wireless LAN guest network. The guest wireless LAN limits access to the internal network and provides access to the Internet only. Click the submenu Guest Network. For the 5 GHz-1 wireless LAN, click Enable Guest Profile. Enter Guest as the network name SSID. Notice that Broadcast SSID is enabled. For security mode, click the drop-down and select Disabled. Scroll to the bottom of the page and click Save Settings. It's important to note that the wireless router is only partially configured. In its present state, it is dangerously insecure. In a later activity, you will learn the important settings that must be made on a wireless network device to secure it. We do not recommend leaving a wireless router partially configured like this for even a short period of time. Typically, home routers ship with a quick start guide that will walk the owner through the configuration steps to secure the wireless LAN. Step 10 is to verify connectivity. At this point, all devices should have connectivity to the Internet and each other. We can verify connectivity by opening the web browser on all devices and browsing to web.isp.net. Let's do this for a couple of devices. Here's the home webcam. We go to the configuration and then wireless interface. You see that we have an IP address. The webcam does not have access to a web browser. Click the wireless laptop in the office, desktop, IP configuration. Notice that it has a full IP addressing configuration. Open a web browser and go to web.isp.net. Because Packet Tracer is a simulation, it will take up to a minute to converge. And we have access to the Internet. In Part 2, you will investigate how email, file transfer, and DNS services are simulated in Packet Tracer. Step 1 is Send and Receive email messages. In the bedroom, click the Family PC, Desktop, and then Email. Click Configure Email to view the settings that are pre-configured in the email client. Note the name and email address that are configured. This identifies the sender's account. The incoming and outgoing email servers are located in the ISP telco network. Close the Configure Mail window and then click Compose. Send an email to your friend Tanya. Enter Tanya at mail.isp.net in the To field and add a subject, type a short message, and then click Send. At the bottom of the mail browser window, notice the Send Success message. Navigate to the cafe. Locate Tanya's computer, which is the cafe customer laptop, and open the email client. Click Receive. Packet Tracer may take up to a minute to converge. You should see the email that you just composed arrive in Tanya's inbox. Click the message to read it. Step 2 is upload a file to an FTP server. File Transfer Protocol, or FTP, allows you to transfer files over a network to a remote server. In this step, you will transfer a file from the home office PC to the FTP server in the ISP telco network. You will then download that file from a server to another computer. Navigate to ISP Telco. In the rack, locate and click the Web FTP server. Click the Services tab and then FTP. Notice that two user accounts are configured, Cisco and MyTransfer. Also notice that the list of files is currently empty. Which of the accounts is least secure? The Cisco account is very insecure because the password and the username are the same and the password is very simple. Navigate to the Home Network and then open a command prompt on the Home Office PC. At the prompt, type a question mark to display the commands that are available. Notice that FTP is a command in the list. Enter the dir command to show the files that are present on the PC. You will transfer the 2021_prospectus.txt file to the FTP server. Enter the FTP command followed by the URL to the FTP server, which is ftp.isp.net. Enter the username and password. We will use Cisco and Cisco. Notice the acknowledgement that we have logged in and the prompt changed to FTP. Enter a question mark to see what commands are available in this mode. Most of the commands are typical file management commands. We will use the put and get commands. The put command sends a file to the server. The get command retrieves a file from the server. Enter the put command followed by the file name 2021_prospectus.txt. The transfer is complete. Enter the dir command to verify that the file is now present on the server. Enter the quit command to terminate the FTP session. Enter the dir command again on the local PC to see that the file is still here. We simply copied it to the FTP server. Step 3 is download the file from the FTP server. Navigate to the cafe and open a command prompt on Tanya's computer. Use the same command and credentials to connect to the FTP server. Use the dir command to see the files stored on the server. Enter the get command followed by the file name. And we get the message transfer complete. Quit FTP. And use the dir command to verify that the file is now stored on Tanya's laptop. Step 4 is investigate the mail server in the ISP Telco network. Navigate to the ISP Telco network and then click the Email server, Services, Email. Notice that the domain name for the server is configured here. Also notice that the two email accounts you used previously are also configured. Step 5 is investigate the DNS server in the ISP Telecom network. Click the DNS server, Services, DNS. Notice that there are 6 DNS entries already configured on the server. For each entry, the domain name is mapped to the IP address of the server that is running the service. For example, the IP address of the mail server is 10.2.0.200. Packet Tracer offers real-time and simulation modes. The work we have done so far has been in real-time mode. In Part 3, we will use simulation mode to observe how network protocols work together to enable network communication. Additional simulation mode tutorials are available in the Help menu. Step 1 is observe ARP and ICMP in operation. Simulation mode only works in logical mode. Click Logical to switch to the logical view. Click Simulation Mode, which will open the simulation panel. The event list will display all the packets transmitted in simulation mode. Right now, simulation mode is paused. Therefore, we do not see any traffic yet. Toggle the Show All None button so that none is listed under Event List filters. Right now, DNS, POP, and SMMT are listed. Now we show none. Click Edit Filters and select ARP and ICMP, and then close the window to apply the new filter. Now under Event List Filters, Visible Events, you should see ARP and ICMP listed. Navigate to the Home Network and open a command prompt on the Home Office PC. Enter the ARP-D command. This clears out any entries the Home Office PC has in its ARP table. The home printer has an IP address of 192.168.100.5. Ping it now. Because simulation mode is paused, nothing will happen just yet. In the Simulation panel, Play Controls section, click the Capture Then Forward button. Click the colored tile next to the first ARP event. The PDU information window opens. Here you can examine details about the selected protocol data unit, or PDU. In this case, you have selected the first ARP message sent by Home Office PC. In the PDU information window, click Outbound PDU Details. Notice that the source address is Home Office PC's MAC address. The destination address is a broadcast, all Fs. Click the Capture Then Forward several times and watch the PDUs as they move from device to device. Continue clicking until you see Home Office PC send the first ICMP message. Here we see that Home Office PC has received an ARP reply from the home printer with the home printer's MAC address. Here's the destination MAC address for Home Office PC and the source MAC address for home printer. This information is necessary before Home Office PC can send an ICMP packet. After learning the MAC address for the printer, the Home Office PC sends out an ICMP echo request packet. It then waits for a reply before sending out the next ICMP echo request packet. Continue clicking Capture Then Forward until the first ICMP echo reply returns from the home printer. Continue clicking Capture Then Forward until the remainder of the ICMP echo request and echo reply messages have been sent and received. There's a new packet, and the third packet, and the fourth packet. In the Simulation panel, click Reset Simulation. Step 2 is Observe HTTP in operation. The Hypertext Transfer Protocol, or HTTP, is used by web browsers to request web pages from web servers. In the Simulation panel, click Edit Filters, deselect ARP and ICMP, and then select HTTP. On the Home Office PC, open the web browser. Enter the IP address for the home wireless router, which is 192.168.100.1. Remember that in simulation mode, traffic is paused. Click the Capture Then Forward button several times until you are prompted for the password. Re-authenticate. Continue clicking the Capture Then Forward button until the HTTP PDU from the home office reaches the home wireless router. Although not simulated in Packet Tracer, in a real network, this PDU would contain the username and password as plain text in this field. The HTTP protocol has no means of encrypting the sent data. Someone on the network could use a sniffer tool, such as Wireshark, to view the contents of the packets and intercept the username and password information. For this reason, HTTP is considered an insecure protocol. Any confidential information, such as passwords, credit card numbers, or personal information, should be transmitted using secure HTTP or HTTPS. HTTPS adds encryption to HTTP. Click the Capture Then Forward until the HTTP PDU for the home wireless router arrives at Home Office PC and the router GUI appears in the web browser. This concludes this Packet Tracer activity, Build a Home Network.